Page 84. Since the orbital paths of the atoms must overlap for the covalent bond to form, these bonds are highly directional. In materials such as diamond, the covalent bonds are very strong. However, the carbon chain structures of polymers is also formed by covalent bonds, and these elements display a wide range of bond energy. The number of bonds that form depends on the number of valence electrons. An atom with n electrons in a valence shell can bond with only 8n neighbors by sharing electrons with them. When the number of electrons n equals 7, the atoms join pairs. When n equals 6, as in sulfur, long chains can form so the atom can bond with two neighbors. When n equals 5, a layer structure can be developed. If there are 4 valence electrons, 3-dimensional covalent bonds can result. The structure of carbon is in diamond. The bonds the calcium silicate chains in Portland cement concrete is based on covalent bonds. Most asymptotic bonds are partially ionic and partially covalent, and few compounds have a pure covalent in ionic bonds. In general, the degree of either type of bonding depends on the relative positions of the elements in the periodic table. The wider the separation, the more ionic bonds form. Since the electrons in ionic and covalent bonds are fixed to specific atoms, these materials have good thermal and electrical insulation properties. Metallic bonds are a result of the metallic atoms having loosely held electrons in the outer and subshells. When similar metallic atoms interact, the outer electrons are released and are free to float between the atoms. Thus, the atoms are ions that are electrically balanced by the free electrons. In other words, the free electrons disassociate themselves from the original atom and do not get attached to another atom. Metallic bonds are not directional, and the spacing of the ions depends on the physical characteristics of the atoms. The atoms tend to pack together to give simple, high-density structures like marbles, silicon down, and blocks. It is movement of the electrons leads to the high electrical and thermal conductivity of metals.